Example 4, for what values of P and Q is A, B, C, D a parallelogram? So everything in chapter 6.4 is about showing something's a parallelogram because something else happens. All right, so we've already determined that if the opposite sides are congruent, both pairs of opposite sides are congruent, we have a parallelogram. If both pairs of opposite angles are congruent, then we have a parallelogram. If one angle is supplementary to both consecutive angles, it's a parallelogram. If one pair of sides is both parallel and congruent, it's a parallelogram. And then finally, if the diagonals bisect each other, it's a parallelogram. So if we want to determine ABCD to be a parallelogram, we need to make sure that P and Q create bisectors for these two segments. So I need this point here, let's call it point E to give it a name. I need E to be the bisector, or the midpoint of these two segments, making AC bisected and BD bisected. So I want BE to be congruent to ED, and I want AE to be congruent to EC. That's what I want to happen. And if they're congruent, that means their measures are equal. So in the case of BE and ED, I want 7P plus 1 to equal 5P plus 3. I need that to be true. I also need, so I'm going to put the word and, I need both of them to be true. I also need AE, which is 3Q plus 1, to be equal to EC, which is 2Q plus 3. If both those things happen, that means the diagonals bisect each other, and the theorem says if the diagonals of a quadrilateral bisect each other, then you have a parallelogram. So here we go, starting with the green one with the p's. If 7p plus 1 equals 5p plus 3, I got a couple variable terms, a couple numerical terms. I want the variables on the same side. I'm going to chop the 5p, move it over, it becomes negative. Chop the positive 1, move it across, becomes negative. In every case, when you change sides, you change signs. 7p minus 5p equals 2p. 3 minus 1 makes 2. If 2p equals 2, we divide both sides by 2 to get p equal to 1. Quick check. If p equals 1, these two pieces are supposed to be the same length. If I real quick work it out, 7 times 1 is 7, plus 1 makes 8. When p equals 1, that equals 8. 5 times 1 is 5, 5 plus 3 is 8, that also equals 8. Those two segments are the same length when p equals 1, so that is the correct answer for p. Okay. The other equation says that this piece here, AE, and this piece here, the same length, so 3q plus 1 equals 2q plus 3. Again, a couple variable terms, a couple numerical terms. I'm going to chop the 2q, move it over left, becomes negative 2q. Chop the plus 1, move it right, becomes minus 1. 3q minus 2q makes 1q. We typically write 1q as just q. And then 3 minus 1 makes 2. There's no division this time because there's no coefficient, so q equals 2. Should be the value of q that works. If we verify over here, 3 times 2 is 6, 6 plus 1 is 7. 2 times 2 is 4, 4 plus 3 is 7. So we can see those are also equal. That's what's supposed to happen. So what values of p and q? Is it a parallelogram? P equals 1 and q equals 2 would make that into a parallelogram.